has arrived today, so I've added these on. Let's have a look. Ooh, okay. This is a review item, kind of. It's a gift to me, but they're doing a campaign, and I've been asked about this many times in the past, or something like it. So I'll explain what it is. Electronic design sticker. It's a USB board. So it's got a USB-A port on there, and it's got some bananas on there. And the idea is you plug this into the front of your power supply. Also got a USB-C, and so you can plug this into your power supply and power it out. And it's got an on-off switch as well here for over voltage protection, just in case you need it. I think default would probably be on, and it is on already. This is called the USBpwrME. So I got emailed probably a month or so ago now from the person that designed this, or represents a company. I'm not quite sure which it is. I think it's probably the person that designed it. I'd like to send you one of these things. So here is a campaign page. I shall sort of links out for this and stick them down below, and I'll probably do a proper review on it as well. Check it out thoroughly. And here's a page, I suppose, gives you a bit more information about it. But the reason I'm saying this is good, because I've been asked many times about this one I've got sitting here in front of my signal and power supply. This thing. So this I was gifted by someone. I think that was from Harold from CMI Zapper. I think he sent that to me. I think it was him that sent it to me. I believe that was him. And it's just really useful for you when I have a powered USB port on a standard lap power supply, and you want to like see what your currents and stuff. Obviously you have to be careful about voltages. It doesn't convert voltage, it's only, you know, for pinouts only. So you make sure it's set at 5 volts, but you can see the currents and stuff like that and control it really nicely with that. Now this is what this is for. Got to make sure you get the polarity correct. It is marked on the front, so positive that side. Has it got the spacing set right? It does. It is adjustable. You can adjust that thing. So that's plug in there, and I could use that instead of this one. And it's got a USB-C on there and a USB-A. It's got some extra features on it, like over voltage protection, things like that, so it disconnects it if it's got over too much voltage, which is a bit safer than using this. So yeah, I'll do a review on that. We'll look at it in more detail later on. Here, I'll show you. Just here. This was sent to me a while ago by someone. I think it was by Harold from CMI Zapper. He doesn't have this on his website or anything that I could see, so I'm not sure if it's just something he made and just decided to send me one as well. But anyway, I've had this here. It's been very useful. People have asked me about this thing in the past because they've seen it sitting here plugged into there like that, because it's very useful having a USB port plugged into your front of your lab power supply. Very good. Now it's very basic. It's just straight in and out, no protection, there's nothing, it's just straight through. That's all it does. So it's a very basic thing, but it's useful. So what I'm looking at today is this thing here. And I showed this in mailbag, which you probably only just saw, I'm guessing. I'm not sure which sequence I'm going to be releasing these things in. This is a similar sort of thing to this, only much better. And I'll explain why. Now before I get into that, here's some information about it. Crowd supply, YouTube video, and the homepage as well. Check those out. I'll put links down below as well. I'll link to them in the description, so if you want to just click on a link instead of trying to type it in, you can do that. Now what this actually is a souped up version of what I've already got, which is basically a protected version. So it's got a voltage protection on it and stuff like that. It will still pass through a voltage up to 20 volts. You can pass through up to 20 volts maximum. You can pass through it. It's still, you know, just a pass through. It's not doing any regulation on that, but it does have protection built in, so you can read all this yourself. It's got USB-A and USB-C ports. It will work down to 3 volts, but I recommend higher because of, you know, safety margins, what have you. Total maximum current 6 amps, and it does have like Type A and Type C negotiated as well. I'm not quite sure what that's doing. I don't know. That's based on pass through. 25, 35 watts, depending on which connection type you're using. So, high voltage protection limit is 5.7 volts, and increasing current is less than 30 milliamps. So it's just idle current, which shouldn't really matter in most cases. If you're running a bench power supply, you know, you may need to allow for that, maybe. I'm not sure about the voltage protection being 5.7 volts. To me it's a little bit high. I think I would have preferred to see that a little bit lower, probably 5.5, 10% up. There is actually a specification for what the maximum ranges are on a 5-volt supply system. I think it was 5.5 volts. I can't remember, but it is actually a standard thing. So 5.7 I think is a little bit on the high side, but it's still better than nothing, which is what I currently have with this one. Right now, if I just plugged in and I accidentally had that set to, 6, 7, 8 volts, 10 volts, whatever, that's coming out of this plug as well. So I have to be careful about that. But with this thing, you won't have to be careful about that. Well, maybe you should, but it's not such an issue. There's this side here. So it gives, again, it mentions 5 volts only because it doesn't do conversions, which is fine. So there you go. So this is what it actually looks like. It's called the USBpwrME, and it's got a voltage protection switch here, USB A, USB C, 2 indicators here for in and out. It's also got an indicator down here for over voltage protection as well. Now these look like MOSFETs. Yep. Oh, yep, that's a MOSFET. That's a MOSFET. That's a MOSFET, I think. Yep, that's a MOSFET as well. That I'm not sure. BW3ZD, and we got a KS-YX, wherever that is. I'm guessing there's some kind of monitoring, like voltage detection and stuff on here somewhere. I'm not quite sure if it's like a microcontroller or whether it's like a battery monitoring system sort of thing. Maybe. So 2513 there. What's that one? It's 1P, is it? 1F. There's one more chip here which I can't see. It's absolutely tiny. Can't quite see what number it is. Is it 1319, is it? 1379? I think it's a 1. Is it 1919? I don't know. Anyway, pretty small chip. Got one more down here. Did I cover that one? Yeah, 4FT. So it's 1319. Yeah, there we go. Kind of see it there. 1319221. Got no idea what that is. We could look up those parts and figure out what they are. On the back, there's nothing there really. As you can see, these are actually adjustable spacing, so if you don't have standardised spacing on your power supply, you can make it a bit wider. So that's alright. Comes in useful. I've seen so much narrower though. I'm not sure if this will go narrow enough. Like that's 19mm minimum, by the looks of it. Can go slightly bigger, maybe. I don't know whether that'd be. For sure, but it can go 5mm bigger probably. But it can't go smaller. Now I've seen supplies where the outputs are actually closer together, not further apart. I've seen both, obviously, but I've seen them closer together as well. That's been a pain. So yeah, it's something to watch out for. So I think initial feedback right now is that these would be nice to be slightly more adjustable, so you can come closer together by a few millimeters as well. And maybe adjusting that voltage protection to be 5.5 volts instead of 5.7. There may be a design reason why they've chosen 5.7. I don't know. It may just be like a standardised chip requirement or something like that. Maybe the chip they've used for detection comes at 5.7, not 5.5. I don't know. Let's plug it in, try it out. Here's my Siglent power supply. I've had other ones in the past as well, but this is the one I've got now, which is Siglent. Done some videos on that, so that will just plug in like that. You got plus and minus on the front here as well, so you can see which terminal is which, so make sure you're getting right around. I believe it does actually protect from reverse polarity as well. Yeah, reverse polarity protection does have that, so if you do actually plug it in backwards, it shouldn't blow it up. Right, so I've got it set to 5 volts to turn this on. There you go, you've got indicator LEDs there. We've got 2 LEDs, so there's the 2 LEDs there. In and out, both illuminated at 5 volts. The over voltage protection is currently turned on. So if I come over here and test out the oops, always get this wrong, and wind this up and try and get this thing to see both. So 5.1, 5.7, 5.8, there we go. That's now turned off. Right, so that's turned off the output. So if I get, I've got this prepared already, so I've got one of these things. For Nursey, we'll plug this in. Is that going to be right up? No, it's upside down. Okay, I've also prepared for this too. Let me show you. I've got some leads ready. I thought I might have to do this. Plug those in, hook this up to the back, get it right around. That shouldn't matter, it should protect itself. There we go. Now, high voltage protection is currently turned on. So I'll turn it off. You've got 5.8 volts coming in. Turn it off. Okay, the output's turned on. And the high voltage protection LED has now come on as well. See how it's a bit better like that. Let's plug this in. So you go, there's a 5.8 volts there. And so it's just passing straight through. There's no regulation, there's nothing else going on. I can wind this up. Now, it's supposed to be able to go up to 20 volts. This thing you can see it's got like a graph on it saying what you can go up to. You know, I think it's going to do like 24 volts or something. So it's perfectly happy going up like this. Let's actually just change this way around. 15 volts as high as I'm going to output of this thing. Let's just shut off because it wants to. High voltage protection on the power supply has gone off, that's why. Let's turn this down. Because of the protection on the power supply, that's what's happened there. Turn it back on. Here we go. So this will say pass through 20 volts, and it does just pass straight through. There's nothing there to otherwise limit it. If I say I have 10 volts going in, for example, and I turn high voltage protection on. There we go, that's turned off. It's all off now, output's off. So that works fine. Bring it down, and you should see it turn back on. 5 volts there, there you go, it's turned on. So I recommend you leaving the old voltage protection turned on if you're using 5 volt devices. If you're trying to pass through to a power delivery device, for example, which can handle that, there's no negotiation here that I can see. I don't think there is. There may be. I mean, it does mention negotiation on here, but I'm not sure how it does that. I'm not that familiar with that sort of stuff. It's not what I normally use, so it's not something I play with. And go down to 4 volts. That's still working. This panel go down to 3. Whether this can do 3, I don't know. 3. No, that's gone off. The output's still on. High voltage protection turned on. That's what happened there. See that? When we go down to 3 volts, that turns on, which is actually under voltage protection. And when it's over volt now, it's not actually on. And it's only doing it for low voltage, not high voltage. So 6 volts right now, it's turned off, but the indicator's not on. So it's kind of like dual function, I suppose, saying it's under voltage, it's warning you that, and normally when it's on, it's warning you that it's not enabled. So which makes sense to me because there's a red light. Red means danger, which is fine. So it works right. And apparently it can do up to 6 amps passing through it. It does recommend you don't run cables through it, but I'm doing this purely for demonstration purposes. Because obviously if you've got cables, you only get voltage drop through cables. If you're doing like an amp or so, it shouldn't really matter. But if you're doing higher currents like it says you can do, that may be a problem. But yeah, that works well. That's really nice. I like the fact that it's protected, which means I don't have to worry anymore about accidentally blowing something up. I can just plug this in here, like that, the right around. Should we try plugging it in backwards? Should we plug it in backwards, see what happens? This is very risky. Let's do it. No current draw, no firing, no problems, no bangs. But we can the right way. Still working, that's fine. Excellent. So we also see a bit of creating current just here. So the specs said less than 13 milliamps, and we're getting 8 milliamps on here, which is fine. That's alright, as long as you know it's there, you can allow for that when you're doing measurements. So that's going to now sit there. That's great, so I'm very happy with that. Very useful. This may still have use somewhere, maybe plug it in somewhere maybe, I don't know. I'm much happier now, I've got something which has got protection built into it, rather than just a straight through, which is always like a big risk of blowing something up. So thanks a lot, Carolee, for sending it to me. I'm hoping I'm pronouncing that correctly. Carolee is the person's name that sent it to me, as in KS. So thanks a lot for that. I'll be putting links down below in the description, so you can go and pick up your own one. Highly recommended if you want to use a bench power supply for outputting 5 volts on one of the channels, like I do all the time. So brilliant. Check links down below. Catch you later.